All right, so let's take a look at section 5.3. Scooch that down a little bit. There we go. All right, talking about inequalities. So if we're talking about an inequality, basically what does that mean? It means that something is what? Not equal. Very good. It's inequality. All right, so it's not equal to each other.
That is what racist. No, sorry.
See what happens? See, you say one thing, everybody goes ballistic. All right.
Not me. No, I didn't.
No, you said the. Anyway, let's go. Shh. Guys, a little self-control would be really, really nice, especially in here. This is one class where I expect it. Okay, so if we talk about inequalities, we're talking about things that are not equal to each other. All right, so let's talk about first something that is equal, then I'll show you something that's not equal. Okay, we call this the comparison property. Let's write that down. Comparison. Okay, so we're going to compare a couple things to each other. Comparison property. All right, it's nothing that can be proven, but here it is. It's basically this. If you have A equals B plus C, but Mr. Hamrick, I thought we were doing inequalities. Okay, that's an equality, right? They're equal to each other. Well, that's true, but I'm going to show you something else. And if C is greater than 0, so this only works if C is basically a positive number, okay? Everybody see that? Okay, or 0. So, I'm sorry, a positive number. It's not. It could be 0, but it's got to be a positive number. I'm sorry, I said that wrong. It will not be 0. It'll be anything bigger than 0. So a positive number. So if C is a positive number, then I'll put a comma right here. This is called an if-then statement. We do a lot of these in geometry. A lot of properties, theorems, postulates, and things like that are if-then statements. So if this stuff is true right here, then A is, I'm sorry, the other way around. Yeah, that's right. Then A is going to be greater than, that's my inequality. Do you remember that from your algebra days, right? Less than, greater than, that kind of stuff. That's the greater than. So A is greater than B, okay? And you could also say that A is greater than C. All right, why? Well, let's just stick some numbers in and see if it's true, all right? So, I don't know, let's say 7 is equal to, 3 plus 4. Do you agree that that's true? 7 equals 3 plus 4. Now, according to this, now C is greater than 0, okay, which means it's positive, so C is positive, right? So everything in here is positive. So, so A must be greater than what? So is 7 greater than 3? Sure. Is 7 greater than 4? Yeah, absolutely. It just kind of makes sense, though, doesn't it? That's why it's a property. It's not really it's not a theorem. You can't really prove it. Okay, it's just a property, and it's true, because if I have two things that add up to be a bigger thing, that bigger thing has got to be bigger than the other two things. All right, that's why they don't write it like that in the geometry book with all the things in there. Okay, but it makes sense. If it takes B plus C to make up A, then B's got to be smaller than A, and C's got to be smaller than A. Agreed? All right, so that's pretty basic, kind of common sense kind of stuff, all right? But we're going to use that in a theorem, okay? We're going to use that idea in a theorem that we're going to do, all right? So let's use it in this theorem right here. So write this down. Actually, I'm going to do this. Instead of me writing it out with this pen, because my handwriting is so sloppy with this thing, I'm going to type it out. Okay. All right, so we're going to call this what is it called? The exterior angle, okay? And you know about exterior angles, right? We've done that before. The exterior angle inequality theorem. Write this down, even though it's in your book. Write it down in your notes, okay? So it says the measure of an exterior angle. So the measure of an exterior angle, let's see, of a triangle is greater than the measure of either remote, remember remote interior angles?
Yes.
Okay, so there it is right there. Let me like bold this or something. Or I could underline it, I think. Oh, that doesn't work. That doesn't work either. I have another program that I've got these keyboard shortcuts that underline it and make it bold, but apparently this program doesn't do it. That's okay. All right, so there it is right there. Everybody can see that? It's a little bit off the screen, isn't it?
Now we can see.
Oops. Why is that not grabbing? It's weird. Anyway, I don't know why that's weird. That's why it's not moving. Anyway, it's good enough. All right, everybody got that? So now, what in the world does that mean? Well, I'm glad you asked. So let me change this back. So here we go. I'm going to draw a triangle with an exterior angle. We've done this before. Do you remember the theorem about exterior angles and remote interior angles?
Yeah.
What is true about it?
The remote interior angles equal to the exterior.
Well, you're kind of on the right track, but not exactly. Can't exactly say it like that.
Wait, what was it?
The exterior angle would be this one right here. So we'll call this angle 1. Okay, and I'm just putting the same letters as the book does, so it's consistent with the book. Now let's take a look at this. Which one is the exterior angle here? Angle 1 is the exterior angle. So the exterior angle, according to the exterior angle theorem that we learned last chapter, I think, the exterior angle theorem says the exterior angle is equal to the what? The sum of the remote interior angles. Okay?
I said that, but I said
all right, so what did our theorem, let's put it up here. So our theorem that we learned in chapter, whatever it was, 4, said this, that angle 1 would equal what and what? According to this picture right here.
B and C.
Angle B plus angle C. Would you agree? Now, this kind of looks like what we just talked about right here, doesn't it? Okay, if A equals B plus C, do you see that? So what is, according to that comparison, what is it, property? Is that what you called it? Yeah. According to that comparison property, then what must be true about angle 1 compared to angle B, or angle 1 compared to angle C?
Greater than angle C.
That's right. Angle 1 has got to be what? Greater than angle B, and angle 1 must be what? Greater than angle C. Right? Would you agree with that? According to that property that we just finished doing. Because we already knew that this was true because of the exterior angle theorem, right, that we talked about in the last chapter. And according to what we just finished talking about right here, angle 1, let's pull that down a little bit. So angle 1 must be greater. So this angle right here has got to be greater than angle B, and it has to be greater than angle C. Make sense? Yeah, it's not too bad. All right, so that's basically what that theorem says. Let's move on. This one, let's put this up here, and okay, come on. Why is it not? Maybe it's because of the pen. That's what it is. Let's see. Come on, grab it. Gavin, please stop. Thank gosh. I think I'd rather you be in the back row. Why is this not? I don't know. I did it earlier. I stretched this out. What the heck? Hold on. Give me a second. Why is that not working? I don't know. Let's go. Let's do this. Guys, let's settle down, please, okay? I'm just trying to do something and you guys go crazy, okay? Just because I'm trying to do something right here does not mean that you guys get to just talk whenever you want. I don't understand why that's a thing with you guys, okay? Just sit there and just watch me just drown, okay? And try to figure this out, and I don't know why it's not working. I don't know why I can't grab this and move it over. I don't know why. I'm going to forget it, and it's really strange why that's doing that. Because I got it to work the first time. I don't know why it's not working now. So here we go. Let's just write it out. So this one's called the greater angle theorem. It's called the greater angle theorem. Gavin, you're not writing anything down. You don't have a pencil in your hand or pen in your hand. You don't have a notebook. You're just sitting there. You know what they say about idle hands? You ever hear that saying? Idle hands are the devil's workshop. You ever hear that? It means when you got nothing to do. When you got nothing to do, it's the devil's workshop. That means when you got nothing to do, nothing to keep you occupied, nothing to keep you busy, then you get into trouble. Would you agree with that statement? That's absolutely true. If two sides of a triangle are not congruent, my goodness, my handwriting's terrible, especially when I get the edge of this because my little tablet is so small. So if two sides of a triangle are not congruent, the larger angle. Sam, see what happens? You say one little silly thing, and then everybody starts talking. You see how it works? And I'm sure that's probably your intention. Why do you have to say it? I don't understand. Just think it, and don't express it. Okay. If two sides of a triangle are not congruent, the larger side is opposite the longer. The larger angle is opposite the longer side. You're like, what in the world does that mean? Well, I'm glad you asked. So let's say we have that. Let's say this may not be really drawn to scale. But we'll put some numbers in here just to, again, it may not be drawn to scale, but that's all right. We'll just go by the numbers. This is L, this is M, and this is N. All right, here we go. So this is basically what this says. Look at it. If two sides of a triangle are not congruent, do we have any congruent sides on this triangle? No, we don't, okay? So it says, then the larger angle is opposite the longer side. So what do I know here? I don't know anything about my angles, do I? No. But I do know something about the sides. Okay, so which one is the longest side? 14 is the longest side. So that shows me, okay, what the longest or the larger angle is going to be. So what is the largest angle here? Angle M is the largest angle. Okay, so this is the largest angle because it's opposite the larger side. What do you think might be true about the other ones? What would the next largest angle be, do you think? It would be N because it's opposite the next largest side. Does that make sense? Yes. Okay. So it goes 14, 13, 12. This is the longest side, the next one, and this is the shortest one. So that means that angle M is going to be the largest angle. Okay. Angle N, I'll make this arc just like a little bit smaller. Okay. Do you see that? That's just a little bit smaller than that one. And then this one's going to be the smallest one. I'll make that real tiny, like that. You with me on that? So that's the largest angle. That's the second largest one, the middle one, and this is going to be the smallest one. And I know that because I know the sides. Okay? What if I did have a triangle? This said if two of the sides are not congruent to each other. What if I had a triangle where the two sides were congruent to each other? I don't know if I've talked about this yet or not. Yeah, I think, did I talk about that? Yeah, okay, that's what I thought. So what if I had this? Yeah, I do remember now. I was forgetting for a second. So let's say that's 5 and that's 5 right there, okay? What does that tell you about the opposite angles? That they were equal to each other. So it's kind of the same thing, isn't it? If these two sides are exactly the same, these two angles are equal. What if this 5, what if that got longer? What if the 5 stretched out and this 5 was bigger than this side right here? This stretched out to like 7 and this was 5. Okay, then the side opposite the 7 would be bigger than the side opposite the 5. I'm sorry, not the side. The angle opposite the 7 would be bigger than the angle opposite the 5. Does that make sense? Okay. So that's it. It's pretty simple. All right. 14, 13, 12. It doesn't have to be those numbers. It could be any numbers. But you take a look at the largest side, the angle that's opposite. You understand which one is opposite? Here's the side. That's opposite that side right there. That angle is opposite that side. So this side, or this angle, I keep messing it up. This angle is going to be bigger than any of the other angles, okay? This angle L is opposite the smallest side. So this angle is going to be the smallest angle out of all of them, okay? 13 is your middle side, okay? And so the angle opposite 13 is going to be your middle angle. Make sense?
Yes, sir.
Yeah. Okay, so it works both ways, though. All right, so if I have a triangle where I knew the angles, what do you think? Let me draw that. So what if I had, again, I don't know if this is to scale or not, but that's okay. Oops, I don't want that. And then right here. So I'm not going to write this down. It's in the book. It just takes too much time to write it all down. So what if I had this? What if, it looks kind of like 90, but we'll make it 100. So let's say that's 100 degrees. Let's say that's 60 degrees. What would this one be if I know that's 100 and that's 60? This would be 20, correct? Okay. So that's right. So let's put some letters in here. A, B, and C. All right. So now I don't know anything about the sides, but I do know something about the angles. But I could tell you which one is the biggest side, which one's the middle side, and which one's the smallest side because I know the angles. Everybody with me? So what's the biggest angle here?
100.
The 100, the angle B. So which one is the largest side? Which one's the largest side? Think before you talk.
AC.
It's AC. It's a side. It's a length. It's not an angle. You can't say C. You can't say 20. Okay? And that's the smallest one anyway. So think before you say something. I don't mind if you give me a wrong answer, but just think about it for a second before you answer, okay? So watch. If this is the biggest angle, then this side, AC, is going to be the biggest side. Make sense? I'll put like a big old tick mark right here, okay? Which one's the next longest side of this triangle? BC. So I'll put like a medium tick mark right there. All right? Well, yeah, I'm just showing you. This is not really the way people in geometry do it. I'm just doing it so you can see the biggest tick mark's the biggest side. The smallest tick mark is the smallest side. Okay? You with me on that? Doesn't mean they're equal because they're one tick mark. And then which one's the smallest one? AB is the smallest one. So I'll put a little tiny tick mark right there. Okay? Everybody see that? So this is by knowing the angles, you should know which one is the biggest side, which one's the medium side, and which one's the smallest side, because they're the ones that are opposite. So it's kind of like the opposite or the converse, and we say in geometry, it's kind of like the converse of this. So what would this say? If two angles of a triangle are not congruent, then the larger side or the longest side is opposite the longer or the larger angle. Okay? So that would be that. And they give it a name. They call it the longer side theorem. Okay, instead of greater angle theorem, they call it the longer side theorem. And you can look that up. That's on page 223 at the bottom. Okay, you can write it down in your notes. I'm just not taking the time to write it down because my writing is terrible, especially on this thing. It's bad enough on paper. It's terrible on this. All right, let's do a couple more theorems. They don't even give these theorems any names because I don't know why. So here's the first theorem that they give you. They give you no name for it, but it says this. And I will write this down. I think we have time. Yeah, we got time to do this. Okay, the hypotenuse. We know that. What's the hypotenuse? The hypotenuse is the what?
The angle opposite.
It's not an angle. The hypotenuse is not an angle. That's it. It's the side opposite the right angle. So it says the hypotenuse is the larger side in a right triangle. Side in a right, I'll shorten right, triangle. Okay? So let's just look at it. Let's try this again. And then like this. And like this. All right, so there we go. Do you remember one of our special right triangles? with the numbers, each side is like a whole number. Do you remember a special right triangle? We talked about it earlier this year. We didn't talk a whole lot about it. But if this was 3 and this was 4, what would this be?
5.
Okay, 5. Is it just because it goes in order? No, it's because it's the what theorem? No. Forget this right here. It's an old theorem you did in algebra and we talked about earlier this year. A squared plus B squared. What is that theorem? Pythagorean theorem. Okay, so if you have a right triangle, you do Pythagorean theorem. So this squared is 9 plus this squared is 16. 9 plus 16 is what? 25. But then that's equal to c squared. So to get c by itself, you take the square root. Any of this coming back to you? Okay, so this would be 5, right? And again, it's not just because it's in order, 3, 4, 5. This is a special triangle. Anyway, let's take a look. So this is a right triangle with sides 3, 4, and 5. It says the hypotenuse is going to be the what? The larger side. Now, why is that? Because of a theorem that we just talked about today. Why is that true? Why is the hypotenuse going to be the largest side of a right triangle? That's right, because on a right triangle, the 90 degree is always going to be the largest angle, isn't it? So the hypotenuse is opposite the largest angle, so the hypotenuse has to be what? The longest side. Make sense? Right? So that's probably why they didn't even give this its own name, because it's kind of like the theorem that we just talked about, right? It has a lot to do with it because the hypotenuse is opposite the right angle. The right angle is always the longest or the biggest angle in a right triangle, and so the hypotenuse is always going to be the biggest side in a right triangle. We good with that? All right, let's do another theorem. Ben, you had a question? All right. Let's do one more. One more and we're finished. Do you remember we talked about doing the altitude? Yeah. Was it yesterday, day before, something like that? Okay, the altitude. This has a lot to do with the altitude. It says the shortest segment. Let's write this one down too. The shortest, close on time here. The shortest segment, but I'm very close to finishing here. The shortest segment from a point to a line. From a point to a line is the perpendicular segment. I'm going to put the symbol for perpendicular. Is that all right? Segment. All right. So let's put a line and let's put a point and let's figure out. Let's put a point right there, point P. All right. And here's line M. So if I asked you to find the shortest distance from this point to this line, would I go like out to here? Would I go to here? That's shorter than that, isn't it? Okay, but is that the shortest distance? What's the shortest distance? It's perpendicular. Well, these are all straight lines, right? These are all straight lines, but it's what? Perpendicular. That right there, did you see that? That right there is the shortest distance, and it's perpendicular, so it must be in a right angle. That's basically what the altitude is, isn't it? The altitude is, remember we talked about an airplane, right, flying across, and they say your altitude is whatever. What are they measuring? They're measuring from the plane straight down, which is perpendicular, right, to the earth. So that is the shortest segment. All right? And now, you got some homework to do tonight. I'm not giving you any homework tomorrow, so let's get this done tonight. It's section 5.3. And it's pages 224 and 25, 224, 225, and you are doing 1 to 18. 1 to 18. So tomorrow is basically going to be a question and answer day, okay? Everybody have a seat. The bell's not rung, okay? Still got a minute. All right, have a seat.
I'm going to go.
So that's your homework. Okay, tomorrow's going to be a question and answer day. So get this done. We'll go over yesterday's homework. We'll go over today's homework tomorrow, and we're going to have a quiz on Friday. Now, this stuff will not be on the quiz. 5.3 is not going to be on the quiz, all right? It's only 5.1 and 5.2. It's all that circumcenter, orthocenter, in-center, centroid stuff, okay? All right, that's all I got for today. Just wait for the bell.